Good morning, my dear friends. In this training session, I'll be explaining about the formulation of acrylic emulsion paint. Actually, I have been giving this series of lectures for the past few weeks. So far, I would have discussed some introductory aspects only, and some of the interested candidates who are watching my YouTube channel regularly, especially in the coating category, they are very much interested in knowing the actual formulation, and Sir is not giving, he keeps on going this as a secret. It's not like that. See, whenever we disclose anything, you should know the basic aspects, the rudimentary aspects about the technology. So we should know the science behind it so that we can design our equipments and our business also, so that it will be a useful technology when it is applied to the society. So that makes the difference between science, engineering and technology. And I'm a serious STEM promoter, that is science, technology, engineering, mathematics or management or medicine. Now, as far as acrylic emulsion paint is concerned, we have got two types. One is applied on the exterior surface, another is applied on the interior surface. So the emulsion paints which are applied on the exterior surfaces like wall, compound, etc. are called exterior emulsion paints. The other one is interior emulsion paint. Let me focus more on the exterior emulsion paint to start with. As I already explained in my basic and preliminary lectures, the paint is nothing but the combination of pigment, resin, solvent, additive. That's it. It's very easy. So what are the major ingredients of paint? In this case, if it is emulsion, you have to use the emulsion as a resin. So pigment, acrylic emulsion, because it is a pure acrylic emulsion paint, so pigment, acrylic emulsion, and then you should have some solvent like water, coalescent solvent. Then additives. Additives are many. So even though they are added in very small quantities, these are all like vitamins to our body. So these are all vital chemical agents that take care of certain important functions like dispersion, surface activity, anti-settling or wetting, defoaming, gelling, and then fungicidal action, bactericidal action, etc. Okay, and we need some additive for balancing the pH of the solution also. Now let us see one by one. First we had to consider water. We'll discuss the quantity later. First let us list out the raw materials. Water, and as I already repeated, a good quality paint is obtained only from three important aspects. The material should be pakka, that is good raw materials, good quality raw materials, and a good process, the recommended process. There are some stages. Okay, so you have to follow strictly. There are some pressure conditions, there are some temperature conditions, there are some pH controls. So all these are very significant. So these are all process quality. So raw material quality, process quality. With all that, you should have the container quality also, where you are mixing. Apart from this, you should have the good quality in your mentality in doing the business. Okay, right. Now we are talking about the raw material quality. We will discuss later about the individual parameters of each raw material. Water. How should be our water, sir? It should be a good water, potable water. It should not be a brackish water or marine water or saltish water. Okay, it should be a good potable water. That's all. But sir, what is this TDS? All these things, that can be discussed later. pH should be 7. That's all. and it should be free from any acid base, okay, any salts. Simply speaking, a good potable water, drinking water, okay, right. Then dispersant, this is an additive. Dispersant means a dispersing agent, okay. And then you should have potassium tripolyphosphate. Surfactant you have to add. This can be a wetting agent as well as anti-settling agent. Otherwise you can have two different varieties, or there are some 2-in-1 surfactants also available. Why we add this surface active agent? Because the pigments are a fine powder. The wettability is a tricky issue here. So in order to make the wetting proper, wetting of this pigment, we need to add this surface active agent. Then during the process, it should not result any heavy foaming, because we are dealing with the emulsion. Emulsion is nothing but a soap. So soap will definitely give some lathering. So it should be free from lathering, otherwise it will disturb the system. Okay, excuse me. Right, let me continue. So, so the deformer, the role of deformer is very important, and at what stage this deformer is added, that is also very important. So about which I already discussed in my previous lectures. You please go through those. Now, we have to consider then the pigment. Here we take a titanium dioxide. So when we talk about this titanium dioxide, we have two types of crystal structures. One is rutile, another is anatase. Usually anatase is heavily used here, but for better quality you can take rutile also. Rutile is costlier than anatase. Apart from that, you have got other pseudo titanium dioxide like monazite sand, or what you call UTOX, etc. Okay, but the original is titanium dioxide, and along with that we can add aluminum silicate, calcium carbonate. So these are all extenders, and particularly calcite is an extender, a filler, right? Now this is also called whiting, okay, calcite. Then we take some that is a cellulosic material like a carboxymethyl cellulose. These are all some thickening agents. Then we have to add the deformer again, okay. After the dispersion is over, in the makeup stage you may have to add some deformer. Then there are some coalescent solvents like corbitol, acetate. Then we can have ethylene glycol. EG means ethylene glycol. Then you may require the main hero of this acrylic emulsion paint, that is pure acrylic emulsion resin. This pure acrylic emulsion, and this decides the entire quality of the paint also. Then we can add fungicidal additive, then carboxymethyl cellulose again, in order to adjust the viscosity or thickening the emulsion paint. Then you can add the residual water. Finally you can top up with ammonium hydroxide in order to maintain the pH in the alkaline, that is a weakly alkaline region. It should not be acidic. If it is acidic, it will have less pot life, okay, right. Now pot life and shelf life. Now let us see the quantity one by one. So water we have to take around 25%. Here I would have used some decimal in order to get 100 kg exactly, okay, right. Here we have around 24 to 25, so let me say 24.15. So I have put 3 digits here. Why? Because when I say 24.15, it is not 15 gram, 24 kilo 15 gram. No, this is 24 kg 150 gram. So you have to remember, when I write 0.43, it is not 43 gram, it is 430 gram. So totally 100 kg, and that is why I have taken the 3 digits decimal. 3 decimals I have taken. Now So you can take 430 gram of dispersant, then potassium TPP 0.110 kg, 0.75 kg surfactant, and a deformer 0.1. Then titanium dioxide, usually 20 to 25% depending on the requirement. For example, I think I already discussed about this pigment binder ratio, and based on that you can have different finish also. Okay, so if you want a matte finish, then the binder ratio should be less. If you want to have glossy finish, the binder ratio should be more. Okay, so it depends. If you want to have in between semi glossy or satin finish, the binder ratio should be optimum. Okay, so I think I already disclosed how about the pigment binder ratio for different types of finish. Based on that you can arrive at the formula also. Now, so we have discussed this titanium dioxide. Then actually that is for aqueous based, that is water based paint. Anatase is better used, but there are some disadvantages of anatase. It has a yellowing tendency because it is, when it is exposed to UV light, it gets yellowing and it gets deteriorated, and it has got a less hiding power also, opacity also. So that is why some people they use the combination of rutile and anatase. Okay, right. And calcite, calcium carbonate, that I have discussed. Then carboxymethyl cellulose, it should be around 9.66. This is a kind of thickening agent. The deformer we take. Deformer, we have got two types of deformer. One is silicone based deformer, the another one is non-silicone deformer. So based on the type of requirement, the type of deformer may vary, and it has to be added at different stages also. Then because this foaming action sometimes it may be predominant at the time of application of a paint also. Okay, so that you have to remember. And then you have got some coalescence. So for sometimes the brush will be sticked at one place, so it should not be sticky, the paint should not be sticky, so it should have a better brushability. Okay, so for which coalescent solvents like carbital acetate and ethylene glycol can be added with this quantity. And here you must remember, when you take too much, then the drying problem occurs. When there is no coalescent agent, it will be sticky, so it will develop a free flow of brushing. So you should not exceed the limit. Then the pure acrylic emulsion, that is a 30, as I already mentioned. So based on the requirement it may vary, whether you require that is satin finish or matte finish, it may vary because we change the pigments also. Then fungicidal additive, especially in the case of exterior, we may have to use this because you have got lot of growth of fungus and algae, so we have to retard that. You have to arrest or prevent the growth of such algae or fungus. So we need to use fungicidal, fungus you know very well, side means kill, so we need an additive to kill the fungus growth. Then again carboxymethyl cellulose to adjust the thickening up of the viscosity, that is the material, that is distemper. And finally we have to adjust the pH in order to be alkaline stage on around 9 pH or 10 pH. Okay, and so with all these we are able to get this exterior emulsion paint. Okay, is it clear now? Right. So I have identified with the pigment, resin, solvent, additive. For example, water is a solvent, and dispersant, potassium, TPP, surfactant, deformer, these are all additives. Then titanium dioxide, aluminum silicate, carbon, these are all pigments and fillers or extenders. Then carboxymethyl cellulose, pure acrylic emulsion, these are all resinous part. And the CMC is also resinous part, it's a thickening agent. So, and we have got solvents, and apart from that we have some deformer, then additive as ammonium hydroxide to adjust the pH. So basically, as I already mentioned, acrylic emulsion paint is the composition of pigment, emulsion, solvent, additives. That's it. Okay, right. Now before attempting to the interior paint formulation, let us discuss some important aspects about the paint, that is the weight conversions. So whenever you purchase the raw materials, you have to give more importance to, you have to demand the technical data sheet and material safety data sheet. These two are very, very important. And similarly, you have to document your own TDS and MSDS for your products also, because your customer will demand. Okay, so let us have these two documents on our record. And technical data sheet means completely, for example, if it is a liquid, you should have color, clarity, specific gravity, viscosity, all these parameters should be given. As far as the safety data sheet is concerned, that is how it should be handled, how it should be stored, how your product should be that is filled, okay, all these parameters, and whether it is inflammable, whether it is environmentally friendly or not, and how to dispose, all these parameters are very, very important as far as MSDS is concerned. Right. Now, I want to give you or enhance you with this important unit conversion. It may involve some mathematics or physics or chemistry, but try to learn this one also, so that it should be useful for your formulation. Because when you look at this MSDS, material safety data sheet, or technical data sheet, you may find as units in a different way. Supply to supply, it may vary. So in order to maintain or in order to convert to your own system, you should know, you should be aware of such kind of unit conversions, especially with regard to, with special reference to specific gravity and percentage solids. I used to talk about this percentage solids very frequently in those days. It means, that is, it represents concentration only. That is how much weight of the solute is present in the given amount of solution. It is nothing but concentration. Whereas what about this specific gravity? It is given as a density, that is mass by volume. This is mass by volume. This is also mass by volume. Then you may ask me, so what makes the difference, and why do we that is, I have two different parameters in order to indicate mass by volume? No, these two are totally different. Remember, when I say density, it is the ratio between mass of the solution and the volume of the mass of the solution and the volume of the solution as a whole. Whereas the density, that is percentage solid in this case, that is concentration, means mass of the solute divided by volume of the solution. That is very important. Now I would like to throw some light on the solution also. Okay. Now let me discuss about solution so that you can have a better understanding about this. So we have got a solution. You may take a pinch of sodium chloride and dissolve it in water, so you are able to get this sodium chloride solution. So the main ingredients are sodium chloride as a solute, water as a solvent. Sodium chloride is solute because it occupies the minor portion. It is represented by 2. So it is a secondary aspect in the solution. But the primary one is solvent. Without solvent, you cannot have solution. So the major portion is solvent. So it is represented by 1. So when I represent the weight of solvent, I can put W1. Weight of solute, W2. Molecular mass of solvent, M1. Molecular mass of solute, M2. Number of moles of solvent, N1. Number of moles of solute, N2. Number of moles of solvent means, in this case, you can even mention as amount of solvent particle, N2, N1. N2 is amount of solute particles. Likewise, you can remember. Okay? Right. Now let me go further. Now the density. So as I already mentioned, the density parameter is very, very important. So here, this can be represented in various ways. You could have seen such type of units in any technical data sheet of any raw materials you purchase. Now, it can be given in gram per ml or gram ml power minus 1. So both are same. Otherwise, it can be represented as gram per cubic centimeter or gram centimeter power minus 3. These two are equal. Then sometimes it can be given as a kilogram per liter also. Okay, in that case you can multiply by 1000, multiply by 1000, or divide by 1000 to get kg, is it not? So let us divide by 1000, and milliliter, that has to be converted into liter, means divided by 1000. It means 1000 can be cancelled. Once again you are able to get kg per liter, correct? Next you have sometimes it is given as a cubic meter, kg per cubic meter also. So before that I would like to inform you that 1 liter is equal to 1 decimeter cube. So you can replace this liter and by decimeter cube. So kg per decimeter cube or kg dm power minus 3 is also allowed. Now I saw in one of the raw materials technical data sheet they had given in kg per cubic meter. So they had mentioned that is toluene 850 kg per cubic meter. One of my clients, he got confused because I have taught him the specificity as 8.85 only. He got confused, and when he used the formula, that is, sir, it should be multiplied by 1000. Huh? It is represented in this case, but we go by gram per ml, so you have to divide by 1000, so you can get 0.85. So how this 1000 multiply 1000 comes? So we will discuss that one also. Okay. For instance, as I already mentioned, 1 cubic centimeter is equal to 1 milliliter, correct? 1 decimeter cube is equal to 1 liter. 1 cubic meter is equal to 1 kiloliter. Kilo means what? 10 cube. So 10 cube liter. So now you have kg per liter. Put kg. Instead of liter, you can put 10 power minus 3 because 10 cube liter is equal to 1 cubic meter. Therefore, 1 liter is equal to 1 by 10 cubic meter. Meter cube, then 1 liter is equal to 10 power minus 3 cubic meter. Done. So instead of liter you can use 10 power minus 3 cubic meter. So when it goes up to the numerator, it becomes 10 power 3. So 10 cube kg per cubic meter. Are you able to follow? So remember, kg per liter is different from kg per cubic meter. So if you want to convert a kg per cubic meter, means multiply by 10 cube. That's all. Okay. And sir, what about this gram per ml? These two are equal only. Okay. So no need to multiply with any factor. I hope now you are able to understand this concept also. Is it clear? Okay. Right. Now let us see the case study. So here, as I already discussed with the experience encountered by one of my clients. So he got this 850. How you got? Now you are able to understand. So 0.85 is the specificity or density of the what? Toluene. Toluene is represented by, this is benzene, and this is toluene. So methyl benzene is toluene. Okay, and xylene, you have got xylene solvent also. So is it going to be helpful? Yes, you should know. So CH3, this is called orthoxylene, and you have got a metaxylene also, paraxylene also. So the mixture of these two is called mixed xylene, correct? Right. Now, and so these are all the major solvents we are using as aromatic solvents. Okay. Then, so 0.85 gram per ml, and that can be represented as 0.85 kg per liter. So you had to convert this into cubic meter. What I told you, multiply by 10 cube, so that you are able to get. Now 0.85 into 10 cube is equal to 850 kg per cubic meter. What do you understand from this? When you take 1000 liter of toluene, it weighs 850 kilogram of toluene. Okay. The density of water is 1. It means 1000 liter is equal to 1000 kg. That's it. That is 1 liter is equal to 1 kg. So likewise, you should be able to remember these aspects. Okay. So if there is any doubt, you can ask me in the comment column also. Otherwise, whenever you watch this video, please note all these points. And if you want to have more details, specific details about some documentations like where from I can get the raw material and what is the machinery setup required for this, and process inner details and the technical details like that is troubleshooting and any statistical methods for analyzing any problems and failure mode analysis, you can have an exclusive that is premium classes with me in through Telegram channel. Okay, right. Now let us discuss about the acrylic emulsion exterior type. I think we can stop with this, then we will proceed in the next class. Okay.